Okay guys, I think we are going. Let me put that back on. Beautiful. All right, so let me start with the TI-Nspire. That looks okay, guys. Seem to be all right. Yep. Guys, I've seen some chats, some questions in the chat. I'll come back and answer those, okay? So, the reason why it's good to have the actual laptop version is for the following, okay? So I have a data set here. You can clearly see it time and year. This is the 100 meters times. Now you typed that in one by one manually, I think, didn't you? Either in the handheld or on the laptop. But of course, it's easier. I'm going to go Doc, Insert, Spreadsheet. And then I'm just going to go and highlight all the data I want. I'm going to do a Command-C, so that's a shortcut on the Mac. Command-C on the Mac. And then I'm just going to go across to my TI-Nspire. I'm just going to click on a second cell, but I'm now going to go back to the first cell, and I'm going to Command-V. So that's already a bonus, isn't it? Can you imagine a larger data set? You know, when we start to work with other investigations or explorations, I might have 50 pieces of data in there. Yeah, some of my grade 11, 12 students took a sample of 50 countries worldwide and analysed some CO2 emissions and things like that. And they just did that. Typing it in one by hand just takes too long. So we just use the power of copy-paste. All right? So that's the first nice trick. But let's just go and remind ourselves now about how to go and plot the graph from here. So it's just a little reminder. We need to label each column and define them as variables. And then when we do the data and statistics, it will pick up variables. So here is time. Oh, time. And here is year. And now Doc, Insert, Data and Statistics. Look, it's tempting to put in a graph, but when you put in a graph page, that's a page for drawing graphs. You type in the formula or the equation for the graph, okay? So this is, we want to actually plot the data that's in our spreadsheet. So that's always data and statistics. And now we just hover over the x-axis. This would be the independent variable, you know, science and maths terms. And the y-axis would be the dependent variable. And this makes sense because the time for the 100 meters, as in the time in seconds, depends on the year, doesn't it? And the more advanced the year, the faster the time, okay? So this is about dependent and independent variables. Beautiful. And then remember, menu, analyze, and it's regression. So regression is a fancy word to fit a model. And we're just going to go for linear here. There are others, which we can play with later. Linear, and there it is. Beautiful, isn't it?
Wait, what's the difference between the one you asked us to do, like when you said put linear or quadratic?
Yeah.
What's the difference?
Well, I think it's in the shape of the model. Linear clearly is a straight line. This assumption means that on average, each year the world record improves by the same amount. And can you see the gradient here? Negative 0.008. So the world record improves by 8 1,000ths of a second every year. That's what the linear model tells me here. Okay? If you choose a different model, then the numbers involved here we have to interpret in slightly different ways. Yeah? A quadratic model, well, that's something to do with ax squared plus bx plus c, and we're not really sure what all those numbers actually mean. For a linear model, it's very, very clear that this is the slope or the rate of change of the gradient. Okay? Questions?
Is our lab report going to be on like with the same data points, or are we going to get new data?
So your lab report is going to be on new data. Okay, so today's lesson is all about you having a little research, thinking about, well, what might you like to investigate? Yeah, things in the past are kind of all sorts of swimming people have investigated, all sorts of throwing events, all sorts of running events. But then sometimes people have gone outside of that and they've been super interested in population growth. You know, they've tried to mix it with maybe CO2 emissions. You know, and it's quite a topical theme, isn't it? CO2 emissions over the last 50 years. So for sure you better get that data and plot graphs and then do a lab report. Okay? So it can be on anything that's of interest to you, and it doesn't have to be in the sporting arena. This is cool because it's, we've got a lot of information out there, but you can choose anything you want. A crossover to science, maybe to humanities, anything. Yeah? But the structure of the report will be similar for all of us. Does that make sense? Yeah. Okay. So I want to do just one or two extra things here. Now on this graph here, as soon as I point to the years, there's this kind of double lines appear. If I hold and move, I can kind of manually change the axes and the start and finish. And if I do the same here, let me just press. If I do the same here, again, you just kind of got to hover. It's a bit fiddly, but I can do the same thing again here, which is kind of useful. But if you want to go into the menu function here, menu, window settings, now you can choose exactly how you want to structure the window. So I'm going to choose 1900 up to 2100, and I want to go down to, I think maybe 8.9 up to 11. Okay, and you can clearly see that I've got everything on there that I probably need. Now, if I was to use my linear model, oh, that's not very good there. If I was to use my linear model to make that prediction, remember y is the time, and in class, remember we substituted 9 for the y, and we solved for x to find the year when 9 seconds will be broken. You can also think about it on the actual graph, can't you? Because here's 9 seconds. And, we're looking around about here. 2020, 2040, 2060, 2080. According to this, it's somewhere over here, okay? But now just check that 9.2, 9.4, 9.6, 9.8, 9.6, so 9.0 is here, okay? So you can kind of do this thing on the graph as well. But this is me drawing by hand, and we've got technology here, so this doesn't seem that it's really doing what we want it to do. So we do have an extra thing here. And this is not drawing a graph of the data at all, which I think would be silly. We want to see what the graph looks like so we can see the shape. But on here, knowing that a linear model might be a good model to use, I'm going to get the equation on this page. And you'll see the advantage to having the equation on this page. So watch. Menu, statistics, statistical calculations, and we're back into the regression menu. So it's a lot more complicated in here. Linear regression, the X list. If you click on the arrow, the drop-down menu, that was, I think, year, wasn't it? And the Y-axis was time. And notice this bit here, save regression equation to F3. Now this means that this particular equation is now stored in the calculator, and it's called F3, function 3. And I'll show you how we're going to use that then. I'm going to press OK. And notice here, it's exactly the same thing, right? The regression equation is y equals mx plus b. The m is negative 0.0079, negative 0.008. This has been rounded off. The b plus 25.69, 25.688. So this is the same equation. And then finally, if I go, yeah, so on this one here, I'll do it again. Again, I'm hopefully recording this so you can keep pressing but I'll do it again just so you can see it visually. Menu, statistics, statistical calculations, linear regression. X list, year, Y list, time. Save regression equation to F4.
because we've already used F3 to save the previous equation. So let's do that again. Do I want to overwrite the data? Yes. And it's the same thing again. Okay. So I've just done it twice, basically. Now, let's use that equation, which is F3, function 3. Insert, and now I will insert a graph. Okay?
And the graph plotting, in terms of function, f of x equals a function of x. This is the same thing as y equals. Okay? But you know that linear function, negative 0.008x plus 25.69, something like that? It's already stored. It's stored as f3.
So watch what happens if I type in, just with the keyboard, F3, open bracket, x.
Notice as soon as I typed in f3, it went bold. Anytime that happens, the calculator's got something already stored as f3.
So look at the axes. What will happen when I press enter and plot this graph?
Tell the person next to you what will happen on this graph page when I press enter. This f3 of x is the linear equation for the 100-meter world record times. You've got 30 seconds. Discuss on your table.
It's a good start. And then window zoom makes sense. And then window settings. And so let's think about it. X min, 1900. These are the years again. X max, 2100. Y min, as long as you get down below 9 seconds, so maybe 8.9 seconds. And Y max, maybe 11 seconds. There's the line.
So this is the same model as the previous. You don't have all the points plotted. Okay? But the reason I'm showing you this model now is for the following reason. I'm actually going to do the same thing again. I'm going to draw a line on here at y equals 9 seconds, and I'm going to find this intersection point here, and then read off the year that 9 seconds hits this line. Okay? So let's try that now.
Again, there's a lot in here, but I'm recording, and we'll play back and we'll kind of learn new tricks on the calculator. Menu. Graph entry. Now you can write it as a function or a relation. I'm going to stick to function, f of x. So f of x equals 9.
This is y equals 9, right? This is a horizontal line. Y equals 9.
If I press enter, you see the orange there. If you point to any place in the white space and hold down your mouse and then just drag the cursor slightly on, you're kind of rescaling things.
I can clearly see this is 9 seconds. This is some approximate date.
But now the power of the calculator takes over. Menu, analyze the graph, intersection. Now the calculator does this in a weird way.
You don't just point at the intersection and it tells you the values. You ask the calculator to search between a lower bound and an upper bound. Then it searches between those 2 points to find the intersection. That's kind of how the program works here.
So all you have to do is point anywhere before, click, point anywhere after, click, and there it is. So what have we found? Well, we found for this set of data that I put in, that for that model, that 2096.91 is the x value at this point. So that's the year, and the y value is 9 seconds. So according to the model that I typed in, the time when 9 seconds would be beaten is 2097-ish. That's interesting, isn't it? Because in class, did we get 2070 something? I'm about 20 years off here.
So something very clearly has gone wrong when I typed in my initial values on my spreadsheet. I actually copied and pasted from a different document to the one you're using. So can you see the idea? If we're using different source data with slightly different data points, we're going to get to different models and then different predictions. Okay? So generally, what questions do you have for me? I mean, for sure, can you show me how to do those clicky buttons again? I'm going to pause the video and I'm going to post it for you so you can see that. So that'll be okay. But the general idea is that we've now got a way through the calculator. We've got the spreadsheet for typing data in, but copy-paste is easier. We've then got the data and statistics page, which plots the two variables quickly and rescales and puts the model in. But then we've also got a graphing page. The graphing page demands that you type in the equation of a graph. This is a powerful page if you want to do further analysis on the model. I think for us to start with, though, this might not be necessary. As we progress through the course, we will certainly be doing a lot more on this page. Okay? So let me pause the video right there.